Hello, welcome. Time for more Advent of Code. I haven't been very good at doing them this year. I pretty much haven't done anything since the last time I streamed. I did go back and try and finish part 2 of day 7, but it worked for the test input, not the real one, and I couldn't be bothered fixing it. But today I have an hour, so let's take a look at day 14, which is the most recent day available at this point. So here we have it. There's a lot of text about a lovely story I haven't been following, so I don't really know what it's talking about. But anyway, the challenge seems to be this: you get this test input, zeros are rocks, these hashes, octothorpes, pounds, whatever. Those are cube-shaped rocks and won't move, and then the dots is empty space. And the idea is that you tilt this thing, and the round rocks roll towards the top. So we go from this first input to this thing where they've all rolled up, and then you just it's all about calculating the load they're putting on, but basically the stuff in this row is worth 10 points each, and then this is worth 9, and stuff is 8 each, and so on. They aren't zeros, they're capital O's. Oh, thanks for the heads up, Will. Yes, I would totally have looked at zeros, even though they're a different character. Yeah, so anyway, you add this all up, and it should come to a total load of 136. So that's what I'm going to try and do. Let me find VS Code. There we go. So I did the boring template stuff I've set up day 14. I've linked it into main and into test like last time, and I've downloaded the test input, so I can make a start on part 1. So in fact, let me just bring up the day 14 sample. Well, that was not what I expected to happen. Day 14 sample. Okay. So my initial thought is, this is a 2D array. I could flip it so I get a column like this. Let me get a column. Wow, I don't really like the flashing, but anyway, I could get a column, and then I could split it into sets of contiguous values. So it'll be like a group of, let me sketch it out. If you imagine rotating it and taking the first column, then what we end up with is, sorry, 2 zeros, not O's. No, 2 O's, and then a single dot, and then a single O, and then a single dot, then a single O, then 2 dots, then 2 hashes, which are, where are they? I don't know where the hash is. There it is. 2 hashes. So we split those into like an array of arrays. So or a list of lists, I guess, because different language. So you end up with this. And then you can start swapping, I think. I don't really know how I'm going to swap stuff in Haskell, but I'll have a think about it. So you start swapping, and the rules are, if it's zeros, then you leave them where they are. So the first one is a 0, not zeros, O's, you leave them where they are. And then we look at the next pairing, and we see that it's a dot first, and then an O, so we swap them. So we get this. Then we look at the next pair, which is a dot and a dot at this point. So we leave them as they are. This does not work, because then you get an O and a dot and you swap those. So it's actually more of a sort, I guess. You got to keep moving stuff. Maybe I could just sort it actually. If I create a rule that says that 0 is less than dot, a sort isn't really going to work, is it? Because you get these hashes. When you hit a hash, you just stop. And the things kind of pile up against it. I feel like I'm kind of on the right line, but I kind of want to sort it until it gets a less than, then we stop. Maybe to think about sorting algorithms a little bit, or just brute force it. Could do that as well. Let's start with the bits that we know about. Okay, so we get some string coming in here. Oops. We'll do our standard thing of just calling lines on it. And then we will show the result. So that should give us a list of things. And then I want to rotate it and take the first one and have a look at it. So is that transpose? And then if we take the head of that, I'll just check that works, but that should give me the first column. Cabal test. Okay, that is the first column. That's cool. So now what I'm going to do is kind of move everything left as far as it will go. So we will have a function called roll, I guess. And that's going to take a list of, sorry, it's a single string at this point, and it's going to return a single string. Okay. How would this work? So the trouble is it's easy to move in one direction through a list, but it's quite hard to move forward and then backtrack and then move forward again, I think. Let's start at this end and work this way. So we flip our list around. And we can say these things don't move. If we get empty space, we skip over it. If we're not carrying anything, if we see a 0, then we start to move it this way. We hit an empty space, so we keep moving it. We hit another round thing, so we pick it up. We see empty space, and we see another round thing, and another round thing, and then we run out. So we drop off the things that we're moving. Let's see if that's going to work. So roll, given some s, is go s. I'm creating go because I'm going to chuck in some extra arguments to it. So go is going to have the things that you're carrying, which is going to be a string, and the thing that is left, I think it remains, and it's going to return a new string. Okay. So the things that we're carrying are initially going to be empty. The things that I'm going to make this a list of characters because it's the same thing, but it just kind of makes a bit more sense to me. So an empty list. Then we have the string, but we're going to reverse it. We can say go reverse. Okay. So the things that we're carrying, let's call these rocks. And if we get an empty thing, then that's equal to rocks. Nice and easy. If we have rocks and we encounter, oops, this and some other stuff, then what do? We drop off our rocks. So we have a string containing that and the rocks. To whatever we're counting so far. And then we're going to add this at the end. Yes, because we're working. Oh no, we're working left to right, and then we'll reverse it again. So we are going to take that string and add it onto whatever go an empty list and the remaining list is. Okay, and then if we have a dot and some x's, then what do we do in this case? That's going to be the dot character, oops, dot character prepended onto go, carry the rocks with us, and look at x's, and then go rocks, and then if it's an O, some x's, what this is go, and then rocks. We'll take our O and we'll prepend it onto rocks. So we'll grow rocks by 1, and whatever's left, and then go, anything else is error, gone wrong. Okay, let me roll ahead of the list just to see what comes out. Okay, that is the right answer for the first row. Need to flip it, so we need to, well, I might not reverse it because I'm not sure it's going to be helpful in calculating the 136, but it is the right output for the first column. So we'll do the second, we'll just map them all actually. So this is going to be map roll onto there. Oh no, don't get rid of head. So transpose our lines, map roll onto it, and then we should get a list of the, we should basically get this turned onto its side. Okay, let's give that a go. Okay, the first one, the second one is just 3 zeros at the top, and then we should have 0, 3 dashes, a hash. So 0, 3 dashes. This is slightly wrong, so I need to, they've come on the wrong side of the hash. So it should be 2 dots, 0, 0. Okay, easy to fix. I did this the wrong way around. So it's rocks, and then that. Okay. So it's 2 dots, 2 rocks, a hash, 4 dots, and a 0. And so on. Okay, cool. So these are correct, and then we just go through, transpose them again, and then we can start to count. We don't need to transpose them actually, we can just take the first of every row, for every list. No, it's probably easier to transpose them, because then we can just add them all together, or count the number of zeros, and then multiply them by whatever position they're in. So we roll it, then we transpose it again. Just make sure that looks right. So now we got a row, it's got a hash and some dots in the hash, which should be the bottom row here. And then a hash and 3 hashes. Yep, and then a single thing on its own. Okay, cool. So for each of these, we can count the number of O's. So what's it going to be? That's going to be, is there some kind of count? Nope, there's nothing in list that does counting for me, so I'm going to have to do L dot, I could do filter of equals O. I need to map that Okay, so then we get, check this as right, but we should just get the count of the number of O's on each line. No, sorry, the existence of O's. Okay, then we just take the length of that. So it'll be length of that. It should be 00130003 and so on. 001303. Okay. Then we zip it with the weight, or whatever the load is putting on for each row. So is it zip map? Is that the thing that I forgot last week? It'll suggest to me. I can't remember what it's called. So we want to zip it with something like that. Okay, so this is a list of int. See what that gives me? Okay, that's correct. So we just multiply these two numbers together and then sum them. So we should be able to map product. Is that right? This is getting a bit long. Okay, so we can map product over that. So you zip with, that was it. Okay. Is it with curry product? It even fixed the currying for me. That's nice. Okay. And then we sum it. No, not quite. Okay. Let's see what this is giving me. Maybe it's not curry product that I wanted. Nope, it is not that at all. Okay, just go back to the zipping for a second. So it should be 3, and it should be 12, that should be 21, and so on. And that's not what I got previously. So we can say zip with, given some pair, it's going to be given some A and B, it's going to be A times B. And it can't apply it to this. Oh. I'm a bit confused now. So this is a list of pairs that comes back. So let me get rid of zip with for a second because I might be misunderstanding what it does or how it works. So this is a list of pairs at this point. So now we should have A and B. And we should just be able to do that. That's correct. And then we sum it. And it passes. Okay. Now I'll let it reduce it for me and see what it comes out with. Whoops. This is going to be redundant curry. Avoid lambda. Remove bracket. Okay, it's much easier. Thanks, compiler. Okay, so we do that. So let's now go compile run. So it gives me this answer. Let's see if that's correct. Probably not. I usually get it wrong. That was correct. Cool. Okay, part 2. That was very quick, so probably part 2 is going to make this a lot harder. Parabolic reflector dish deforms, but not in the way it focuses the beam. You have to move the rocks to the edges of the platform. Okay, spin cycle, twist the platform 4 times so the rocks roll north, west, south, and east. For each tilt the rise rocks roll as far as they can before it tilts the next direction. After one cycle, we finish rolling the rise rocks in all 4 directions. Okay. And calculate the total load after, oh goodness, a lot of cycles. Okay, this is going to be annoying. Maybe it won't be. So let me go back to main and let me go back to test. Where's the test? So it's saying total load on the north support beams is 64. So this part 2 is 64. Okay. So a spin cycle is going to take a string. Is it going to take a string? It's going to take a list of strings. I'm going to, oops, list of strings. So we're going to tilt it north, which is what we did originally. In fact, let's just take a look at that. So tilt north, given some list of strings, return some list of strings, and that's going to be so tilt it north. I mean, I know what I did here previously, so let's just do that. So tilt north is, we have our lines, so we want to L dot transpose of map roll of L dot transpose. My brute force solution to part 1 for about 10 minutes. Part 2 is running now, and it says 37 hours remaining. Good. My part 1 ran a bit quicker, but I'm worried now about the length it's going to take for part 2. Okay, so what's this going to be? This is going to be spin cycle of lines, and we want to show this. Okay, haven't done very much. I'm hoping it will just spin it. Oh, I didn't mean to run it. I want to run the tests. Okay, so this should be this is this output where this is at the bottom and we're moving up. And is that what I want? No. However, it might work. Which way does the spin cycle go? So spin cycle goes from north, then west. So west, we want to take this, each of these, reverse them, and then roll stuff. Okay. I'm just going to add in a pretty, can I add a pretty printer? Just say join of that. It's not join, it's unlined. What am I talking about? Is that easier to read? It is. Okay, cool. So I've basically flipped it over. Can I roll west though? So if I roll it west, I want everything to go this way. So to go that way, what I actually want to do, I think, is put reverse into there. And take it out of here. And then replace this with tilt north. And just make sure that still works. So we expect part 1 to still pass. Yep, cool. Part 2, it's worked okay. Okay, so now I can roll, and roll pushes things to the right. Oh, sorry, part 2 with test input at 10 minutes. Okay, yeah, I'm worried about time. Probably something really clever we can do, but let's just do a naive thing. Okay, so what have we done? We've tilted it north, and now we want to tilt it west. So tilt west, give them some string, because it pushes everything to the right hand side and we want to go left. That should be, tilt west is just map of, roll it reverse. So now I expect this thing again, but everything should have moved to the left as much as it can. Wrong left. Oh, is that correct? But I've reversed all my lines. So I expect to get a 0 and then lots of dots, and then a 0 and 4 dots and a hash. 0, 4 dots and a hash. Okay. So I've rolled them the wrong way. I've got the right answer, but they've gone the wrong way. Okay, and then we want to go south. Maybe it doesn't matter actually. So tilt south. It's going to be actually tilt north. Is that right? L dot transpose. See, because we're upside down, I think we can just run tilt north again. This is my expectation. So what we end up with is all of these zeros butted against a hash. 2 hashes actually. Yeah, okay. So we just roll everything south, and then we roll east, and we'll flip our list around along the way. Kind of by mistake, but it'll help. I might just do tilt west again. Okay, so we get a line with a single hash on it, and then a line with hashes but the 0 butted up to the right hand side. Nope, that has gone wrong. That one's correct. It's 4 dots, hash, 3 dots, and the hash. Oh, this is correct as well, sorry. That's right. And then we get this with a hash and then dot, dot, dot. Okay, so after 3 cycles, we should get this input. Not that. So, how do you repeat it multiple times? Repeat 3 of that. It wasn't bad in Rust, but more imperative than Haskell. Yeah, I'm worried Haskell's going to be horrendously slow. So we've got an int. Is it the spin cycle you want to repeat, not the online stuff? Oh, you're right. Sorry, yes, it's just... Yes. So it's repeat 3. So I'll put the unlines here. Repeat 3, spin cycle, unlines. Okay, so we go from an int to something that takes a list of string and does that. And we're going to take an initial input, which is a list of string, and we're going to return a list of string. That's not right. So repeat 0 is equal to empty list. We don't care what comes in. Well, actually, repeat 0 times is going to be the input. Oops. We don't care what the function is. We just want to do it. Repeat x, some function, and some input is repeat x minus 1. I'm going to assume this is always positive numbers. Ambiguous occurrence of repeat, so repeat is already a thing. What's prelude.repeat do? Oh, it repeats a list multiple times. Let me call this repeat cycle. And this will be a repeat cycle. Okay, so we do this applied to f of s. Does that work? So they get at 3 cycles. That's the same. That's the same. That's the same. That's the same. So it's looking okay. So it is actually repeating it. But doing it this many times is going to be slow. Okay, very slow. Prelude to detect cycles function. Okay, so just brute forcing is not the way to go. Okay, so if a line does not have anything in it, then we don't need, it doesn't have any rocks in it, then we don't rule it, but that's not really super helpful because stuff might roll into that row later on. What can we do? So what I want to say is we run a cycle, and if the output is the same as the input, then we stop. So let's let s prime equal fs in if s is equal to s prime, then we just return s, else that, oh sorry, f of s. So in theory that should stop when it gets a repeated thing. So if we run a cycle and we get the same output, then nothing is going to change by running the cycle again. Give that a whirl. Still not fast. Okay, there might be something else that we can optimize. While that's running, let's have a quick look at this. So what can we say? This is empty. This hasn't changed. Why has it not changed? Okay, we can see that nothing can roll into this bit. Is that true? No, we can't see that. Look at the first row. Okay, so stuff can roll. If you roll everything north, stuff can roll into it. And you're rolling left, west, and then south. Everything that was in here will roll out. And then when you tip it east, nothing can roll back in again. So in theory, you can work out that nothing can roll into this. Nothing will stay in there. And why do we know that? We know that because when we roll it west and then north, it's empty. There's nothing blocking. So west and north has got nothing that can't escape. This one, when we roll west and then north, nothing can escape. No, this one cannot escape. So we know there's one thing that can't escape. Here, why are there two things that can't escape? So one thing can't escape. It's not because of that. Because if it rolled it west, it'd be sitting here, then south, and then east. How come they've ended up back here? If we roll it north, what do we start with? Hang on, let's look at what we start with. This is it rolled north. Okay, then we roll it west. And then south. So one thing will be trapped here. Hang on, west would give us two things on that line. So this one, when you roll it south, will get trapped here. And this one will end up here. So you'd have these two. I don't think that's where it gets trapped. 2, 3, 4, 1, 2, 3, 4. Could be in that level, and east. I can't really see why that one got trapped. Is it finished yet? No, it's still running. Why did I get trapped to one cycle? It's also pushed them down quite a lot. Let me try it again. So we roll this north, and we get this, and we roll it west, and that'll get stopped. Those will all roll, that will roll that way. Ah, these two roll as well. That's what I missed out. Okay. Then you roll it south, so you'll get two sitting in this level. You will get this one, which will roll down and hit this. So that can't escape level 3. And this will end up with 1, 2, 3, 4, 5, 6 things in it. So that there'll be something stuck here. Then when you roll east, you end up with, rolling east doesn't really matter. Like it matters for the next cycle because that determines the starting position, but it doesn't matter for the number of things in a row at the end of a cycle. Okay, so then we get to here. Can we now determine how many things can leave? Because what I'm wondering is, can we start dropping off things that can leave? Although, if that were the case, then my cycle detection should have kicked in. Does my cycle detection work? Let me just replace this for a second. That's the, oops, that's original. Let me just replace it with ID. And, oh, this is going to be annoying because there's a lot of stuff that is unused. Okay. So we're doing this a billion times, but it shouldn't change. Okay, so it seems to work. Like it stopped immediately. So just detecting when nothing has changed after spinning is not quite enough. So we could carry, maybe the cycles are like longer loops. So we could carry the full history and say, like, if we've seen this shape before, stop. And we want to hash, well, we could store the whole thing, but we could also just store a hash of things we've seen before. Maybe let's just go naively. So we will say repeat cycle is go empty list of everything else that's passed in. So go goes from a history, which is a list of strings, to int, to the function, which is list of strings, to list of string. Then we go to list of string, and we go to list of string, and now this is not if s is equal to s prime. Oh, sorry, these need to be goes. First of all, let's just indent this. And these become go. Am I running this? It's gone very slow. Okay, so we don't say is s equal to fs. Okay, now we need history. So we don't care about the history there, but the history here we do care about. So if s prime is an element of s, not s, sorry, h, then we go again, but we go with s prime put onto the head of h. Okay, let me just do it for 3 cycles. Still seems to work. Looks like roughly the right answer. So what happens, oops, if we do it with 1 billion cycles? Ah, stopped really quickly. Is it the right answer though? Did I save the file? Okay. So we've seen the cycle before, we know where it ends up. Maybe. I don't know if that's true or not, but it stopped very fast. So we'd previously seen the cycle. Okay, and now we want to do our summing up thing. So we could say like sum load, I think it was called, and that's going to take a list of strings. Is that right? Yeah, list of strings. And it's going to return an int. I believe it's this. Some load, not load. Is that? It's a sum of zip with map. Okay. So in theory, we can say some load of that. And here we can say, not on lines, but show of some load of that. Okay, it's quick, but doesn't work. So first of all, if we get something we've seen before, return the thing we've seen before, not the thing that was fed into us. But that still doesn't fix it. Okay, so on the plus side it's quick, but on the downside it's wrong. So what do we do here? If there are no cycles left, we stop. That's easy enough. If there are some cycles left, then stop highlighting. If there are some cycles left, then we spin it, and we get some new result back. if we've seen this spin before in the history, then we stop spinning and we return that. Is that going to necessarily where it's going to end up? Because it's not there. Sorry, go back to this example. I need to calculate it after this many cycles. Okay, so what we can do is calculate the number of times we spin it before we get a loop. And that'll give us like a spin length. And then we can work out how many spin lengths. It's basically 1 billion modulo number of spin lengths, and then we spin it that many more times, because that's where we'll get to after a billion spins. Okay, so this is not repeat cycle now, this is find cycle. And it's not going to return a list of strings, it's going to return an int. So this is also going to return an int. Okay, so if we get to the end, it's going to be the original number that was passed in. Okay, we'll just grab that. And that's going to be whatever was originally passed in. This was like orange x. The original x. The original x. At this point, we just want the length of the history. Okay, so let's see. Oh, we can't load. Let's just show that. Okay, so it says after 9 spins, we get a repetition. Okay. So then we want to find the remaining cycles. Which is, I'm going to do this separately. Let's do it here. Okay, this is going to give us an int back, and then we can say, given that x, we want this number, modulo x. I do that in Haskell. Is it just mod x? No. Modulo. No. Modulo. No, not in base. Anything that goes from an int to an int, that'll be fine. There won't be any of those. In base. I would like just int to int, not things that kind of match. Oh, so it's int to int to int. Rem int or rem. It's remainder one actually. It's true. And what? Oh, I didn't need to bracket that. Okay, so in theory, given that number, I then want to say, oh, I've lost my repeat cycle, I want it back. Repeat cycle of spin cycle of that number. I'm just going to quickly re-implement it. I don't think this is right. Repeat cycle, what's this going to take? It's going to take a function which goes from list of string to list of string. And it's going to take a number of times, which is now the second argument because of the way it worked. And it's going to be a list of string and repeat cycle. Oh, we need an initial string, don't we? Okay. Let me move this into function. So repeat cycle is going to take a number, the number of times we want to repeat it. It's going to take our function, which goes string to string, list of string to list of string. It's going to take an initial value, which is a list of string, and it's going to return a list of string. So repeat cycle, given some x and some function and some initial s, we're going to say let x prime equal to, can I say rem x? No, it'll be flip rem x applied to find cycle of x and f. So that's the number of times left to do it in go x s. No, go x fs, sorry. Go x prime. Well, we don't need that. We actually have these things. Oh no, we do need to pass them in, sorry. X prime, f and s. So go is going to go from number of times to rotate it this time. The function, which is list of string. I feel like I'm repeating some code here, but that's okay. It's going to take an initial list of strings and it's going to return a new list of strings. So again, go 0, don't care what the function is, some input is equal to the input we were given. Go with x prime prime f. Oh goodness. The right things to type here. X prime prime, f prime, and s prime is what we're going to do. We're going to say go again with x prime prime minus 1, f prime. F is always the same. We don't need to pass f around. So the string we want to pass in here is going to clash with s, isn't it? So given some s prime, we're going to go again, but this time we're going to go on applying f to s prime. Okay, find cycle return an int. So we can say cycle length is equal to that, and then the remainder is equal to x rem cycle length / type string to int. I'm missing something here. I'm missing the s off there. Okay, cool. In that. So here we can say repeat cycle, then this number, and spin cycle. Okay, and then if we do our, what's it called, sum load. I don't think it's going to give me the right answer, but we'll give it a go. No, it's the wrong thing. Okay. So every 9 times you get the same result again. You get back to the start. So we take a billion mod 9, or look at the remainder divided by 9. Then that should say there are this many spins left to do. I think. Cal REPL. So we have this number. Rem 9 gives us 1. Is that right? It's divided by 9. So then what's that number times 9? As an int. Is that, it is indeed 1, that's the difference. So, okay, it's one more rotation from the point at which we got to when we got the loop, not from the first step. So it's not just int. It's going to be the length of the cycle and the position that you're in when you get to the end of the cycle. So this is going to be original x and s. This one's more interesting, so it's going to be the length of h and s prime Okay, so now we can deconstruct this. So we got cycle length, and we got S prime, and then we use S prime here. Stop it, keyboard. Wow, that was weird. We get that. I don't imagine that's going to magically give us the right answer, but let's give it a go anyway. So the idea is that we spin it, we find the spin, then we say we've got one more spin to go. Part 2, expected 64, but got 129. 129 seems familiar. Was that the first one? No, it was not the first one. Okay. Now what's going on? So we spin it 9 times. And we're back to the same point. No, not quite. So we need to know where we found an H. So it could be an element of H, but it might not be the first element inside H. So we can say IDX, and now we put on a case time. I'm just going to destructure this. So we can say in case index of, oh, it's a thing. It's going to be probably L dot index of. Let's find out. It's probably going to be H and S prime of nothing. So we haven't seen it yet. Then we go again. Where do we get just I? Then what's going to happen? We're going to spin it. The actual spin length is going to be the length of H minus I and then S prime. Not L dot index of. Just index. No, undo that. Things that go from a list of A and an A to an int in base. Element index. S prime and H, there we go. Okay, that can go away. And what's that going to give us then? Get rid of time, instantly. Okay, this gives us the same thing, it seems. So if we just show find cycle, does it give us the same thing? And then I can just comment this out. No, now we divide by 3. Is that right? So our cycle length is 3. Okay, so then we want to spin it 3 times plus the modulo. No. Sorry, we need 3. We need a triple here. We need the number of times before the cycle starts. then the length of the cycle. So in this case, we would spin it 6 times and then one more. So it's going to be a triple. So the base number of spins, the length of the cycle. So it's going to be, we spin it 0 times and we spin it all the times. And here we say, we spin it I times, and then we spun it another, whatever this difference is, number of times. Okay, so this is then going to be initial and that, and we're going to spin it initial plus R times S. I don't think this is going to work. I have no confidence. We've got 6 and 3, but I don't know if that's going to spin the right number of times. And this is some load of that. Still get 129. So we spun it 7 times. If our cycle length is 3, but we only start cycling after 6, that seems a bit weird. It means that, does that mean we're always guaranteed to get another cycle? There's also the horrible possibility I'm out by 1 somewhere. Like I wonder if it's some horrible, if it's 1, then stop. I'm just getting desperate now and trying random things. Okay, so what I think is happening is you spin it 6 times and then every 3 spins it cycles. So that means of the billion cycles we want to do, it should actually be x minus the initial. So of the 1 billion minus 6 things, it'll repeat every 3 times. So we need to find out how many things are left after it stops repeating. And then we add that number onto the initial number of cycles. And then what? Then we start from the beginning, we do it the initial number of times, and then we do it however many are left after the end of the cycling through. Well, we ignore all the cycles and then we just do the remainder. Now we get 133, just get random numbers coming up. Okay, so we do it 6 times and then we do it R times. And we start, we don't need to do the initials, I don't think, because we can do the S prime thing. 529. Yeah, because this is always going to give us 1 because it does 6 times and starts cycling. Maybe my cycle detection is dodgy. Because I'm saying, if you've ever seen this before, stop. Because I suppose it makes sense. If you've ever seen this before, then you know that when you turn it, it'll give you the same result. Okay, so when you start with S, the first time you come through this loop, stop hovering. The first time you come through the loop, that will be 0 rotations, history will be empty. Then we do 1 rotation. If we've seen it in history, which we won't have done because history is empty, then we get nothing back and we go again. And now we have our history, which has got this cycle put onto it. Okay, we have 1 less available. We pass an F again, which is fine. And then we apply F to S. Why do we apply F to S? We already have that. Doesn't really matter, but it seems a bit unnecessary. Okay, so we keep doing that. Then we go again. So next time we come in, this S is now what used to be the S prime. So it's our rotated thing. Our history's got S prime as well. This is just a guard to make sure we don't hit 0. This stays the same every time. I don't know why I pass it in. So we take the thing we're given, we rotate it again, we look up in history. We've now done 2 cycles. Okay. In 2 cycles, we look up our rotated thing. If it's in the history, then we just turn some stuff, otherwise we keep looping. Okay. Let me just stop passing some stuff around I don't need. This is init, and this is going to be in init s, initial value of s. This doesn't capture that, okay. We need to pass f in because we know what it is, okay. Come on then, get rid of that. Okay. So we could get rid of this guard and assume that we'll always find the cycle, but let's keep it for now. So, okay, let's imagine it goes through the first time, doesn't see it, goes through the second time, it sees it in the history, which means it's done 1 rotation. Oh, okay, let's imagine it goes through the third time. It sees it in history, it's done it's done 2 rotations in a sense, and then seen a loop. So what we can say is that what can we say here? We can say the loop size is 3. It just feels like I don't know. It's really hard to tell if I'm just over counting somewhere. Or if, why did that would come back to 129? That's a bit weird. That does confuse me a little bit. Oh, because it's the same. Am I doing it one time too little? I am not, but it's a different answer. What are we saying here? We're saying we've got to do it one more time to make it up to the billion. So we ignore all the times it's repeated and we do it one more time. And actually get us to 1 billion rotations. But I'm not getting the right answer. Let me just repeat this 3 times and we'll see what it spits out. Is this correct? Instead of show, we can say unlines. Okay, so we get the first 3 rows should be pretty straightforward. So the hash and then 0 at the end and then the 2 hashes. Then we get that one stuck here. Okay, then we get these ones. Then we get this line. Look at that. Yeah, it looks pretty correct. So that has no cycle in it, so it's going to hit the 0 case here. To avoid repeating this, I could say something like the answer is find cycle, and this time we use R, we still use F, and we use S prime in there. And we just return the answer. And we get rid of this repeated thing. So we still get the same answer for 3. That seems okay. So instead of 3, we want the 1 billion, which I've lost now. This many cycles. Now I think we get this for some reason. Okay. And then we have some lines. Oops, not some lines, it's some load of that, and we don't want to unlines it, we want to show it. Okay, this gives us the wrong answer, but I wonder actually, what happens if I unlines it and repeat cycle once? The reason for that, I just want to make sure that this matches the first rotation. So I think that did match. I think I checked that one. Okay, so 2 spin cycles. Just make sure I'm not accidentally at some point inverting it. 2 spin cycles does look correct. Okay. So now I'm a bit confused. Just make sure rem does what I want. So 100, rem 9 should be 1, rem 8, I don't know what that is. 4, it seems reasonable. Well, there are 11, 12 8s or 96. Yeah, that seems right. I don't know what that is. Okay. But it was suggested that this, when you divide, there's that many remaining. 1 billion should easily fit in an int. So I don't think it's a rounding error on that. Well, rounding, sorry, whoops, some kind of overflow. 1 is the right answer there. Okay, I'm running out of time. One last thing to check maybe. So we get our spin cycle. So we find it repeat every 3. So this will come back and say we repeat every 3 cycles. Okay, and when we find repetition, this is where we were. So what I want to then do is take S prime and cycle it cycle length number of times. And that should give me back two things which are identical. So given an A and a B, I want to say A is equal to B, so this is uncurry equals equals. How far are they going to go? That far, okay. And this should be, oh, okay, if I take S prime and cycle it 3 times, I don't get the same thing. Right, that's helpful. Why not? Because it should be starting from the next position. But that's still false. Oh, that's interesting. Here, can I just map on lines or something? Nope, I cannot. Can I? Say given, what have we got? Sorry, given an A and a B, can I turn that into unlined A and unlined B? No. Why not? Maybe it's like that. So this goes back a pair. Oops, a pair. That's the problem. Use bimap. No. And then that's really unhelpful. So we want to say this is equal to this. And this is a really difficult way of reading them. I could probably unline that again. So we got a pair of strings. Now, I think that's the best I'm going to get. Where do they differ? So the last line is different. They differ quite a bit. Okay, I'm going to stop because it's getting quite late. I'm not sure I'm going to get to the right answer. I think my cycle detection is wonky, or I'm assuming too much from it. It does feel as though if you've seen something before, then you should get the same result by flipping it. So I think I'm just slightly out in where I'm picking up again, or how I'm working out how many flips left to do. Okay, but thanks for watching along anyway. Sorry I didn't get to an answer with this. Maybe we got close, maybe we didn't. I don't actually know. But I'll do one more next week, I think. So next week is 21st, I should still be around. So I'll do one next Thursday. Hopefully go a bit better, we'll find out. But yeah, so hopefully see you next Thursday. It's going to be quite a late one. It's probably going to be quite challenging, but we'll see how it goes. But yeah, thanks for watching along, and hopefully see you next time. Goodbye.